Hi, welcome to Linear Collisions in Advanced Physical Science. If you consider two objects speeding toward each other, when they collide, according to Newton's third law of motion, several things must take place. The forces that they exert on each other must be the same. The times of their impact must be the same. Therefore, the impulses the two objects collide with are also the same. If the impulses are the same, that means the momentums are also the same. That means that in any collision, when two objects collide, their momentums, combined momentums before the collision, must equal their combined momentums after the collision. The conservation of momentum says, in the absence of an external force, that being gravity or friction or anything else, the total momentum before the collision is equal to the total momentum after the collision. There are three types of collisions. The first collision is elastic. This is a 2-to-2 relationship, where you start with two objects before and end with two objects after. This is an example of an elastic collision. A car with a mass of 1,000 kilograms moving at a velocity of 20 meters per second collides with a truck that has a mass of 3,000 kilograms and is moving at no meters per second. So what happens in this collision is you find the momentum of each object before and the momentum of each object after. Notice that we don't know the velocity of the car afterwards. Clearly, he bounces backwards, but at what velocity? So the momentums are 20,000. The total momentum of the system is 20,000. Doing basic algebra, we get the velocity of the car afterwards to be a negative 10 meters per second. The second kind of collision that we encounter is an inelastic collision, a 2-to-1. Notice that you have two objects before, but one combined object after. In this example, the car sticks to the truck. So again, we find the momentum of the car, the momentum of the truck, and then the momentum of the two of them together. Momentum, remember, is mass times velocity. So again, the combined momentum is 20,000 for the system, divided by 4,000 gives a velocity of the wreckage afterwards of 5 meters per second. The third kind of collision is actually just an inelastic, but it's backwards. So we're going to call this an explosion. This is a 1-to-2, where you start with one object, a combined object before, and you end with two separate objects after. This is like firing a gun. Suppose a 4-kilogram rifle is loaded with a 0.01 kilogram bullet. When the rifle is fired, the bullet exits the barrel at a velocity of 300 meters per second. How fast does the gun recoil backwards? So the momentum of the system is actually 0 because it's not moving ahead of time. Solving that algebra problem, we get a velocity of the recoil to be a negative 0.75 meters per second. In this example, you have Granny scooping up Timmy as she runs around the ice rink. There are two objects before and one object after, therefore this is an inelastic collision, and the momentums of each person before and after has to equal the total momentum, so the momentum of the system is conserved and the velocity of the two of them afterwards is 4 meters per second. So you have three kinds of collisions. In every type of collision, whether it be elastic, inelastic, or an explosion, the momentum of the system before has got to equal the momentum of the system after.
Walk you through the use of this simulation. So you're looking at the collision carts, and first I want you to look at the very bottom. The very bottom, you have your three types of collisions: elastic, where you have springs attached to the carts and they're going to bounce off of each other; inelastic, where you have magnets on the carts and they're going to stick together; and then an explosion, where there's a little firecracker between them and they're going to bounce apart. You are able to set the mass of each cart as either 1, 2, or 3 kilograms. And the velocities, remember that direction does matter. You can set the velocities as being positive, meaning it's going to go to the right, or negative, it's going to go to the left. And in order to play the simulation, in the upper right-hand corner, you hit the start, the cars will collide, and then you want to hit the pause as soon as you can after the collision. That way you can gather all of the information from the simulation without having to replay it several times. In order to reset everything, you simply hit the reset button in the upper left-hand corner.